Hi everyone, today's lesson is for Algebra 2 honors students. This is Chapter 6 Logs Quiz Review plus some challenge problems. So let's get started. Learning targets, review learning targets for 6.4, 6.8, 6.9, and 6.10. Challenges that we didn't exactly get to last week. These are also on the video from last week, so you can reflect that as well. Case 1 is solving exponential equations. And for this problem here, we want to try to get the bases the same. So I'm going to make 3 the bases. So 3 to the 4x plus 1 is equal to 3 to the third power to the 2x. Bases are the same. I could set my exponents equal to each other. So I have 4x plus 1 equals 6x. Bring the 4x over. I get 2x equals 1. And then x is equal to 1 over 2. Okay. Case number 2, we're not going to be able to get the bases to get the same. So we're going to take the inverse of this exponential equation and bring this out front. And so we go 4x plus 1 times log of 5 is equal to log of 8. And these are base 10. For this problem, you have a choice. Okay. The first choice is to distribute this log and solve for x. The second choice is to divide by log 5 and then, solve for x again. So for this, I'm going to use my calculator for this problem. I'm going to get 4x plus 1 is equal to log base 10 of 8 divided by log base 10 of 5. And so in doing that, I get log base 10 of 8. You guys use your calculator. Divided by log base 10 of 5, and I get about 1.292. So I get 4x plus 1 is equal to 1.292. I'm going to subtract 1. I get 4x is equal to 0.292. So I'm going to subtract 1, and I'm going to divide by 4. And then I get x is approximately 0.073, and then that's my answer. Put your answer in a solution set. Verifying your answer, you're just going to plug this back in for x and then solve. For this problem here, this one is a little bit tricky for sure. We want to get the bases the same on the left, and we want to get the bases the same on the right. So in order to do that, first we have to combine the x's and combine the left side and combine the right side. So I'm going to get, on the left side, I get 3 to the 4x plus 2x. So that's 6x plus 1 is equal to 4 to the x plus x. So that's 2x minus 2. I'm not going to be able to get my bases the same. So what I need to do is, again, log both sides. But in this case, this is a little bit different than the last one because we have 2 different bases. In the last case, case number 2, when we logged, it ended up, being the same. So bringing this out to the front, we get 6x plus 1, and then I'm multiplying that by log base 10 of 3, is equal to 2x minus 2 times log base 10 of 4. I'm going to actually, for this problem, distribute these logs. Now, you do have a choice in doing this. If you distribute the logs, what ends up happening is this. You get 6x log 3 plus log 3 times 1, which is log 3. And then distributing the log 4, I get 2x log 4, 2x log 4 minus 2 log 4. And then, of course, we're trying to solve for x. So we want to get both of the x's on the same side. So I'm going to move this 2x log 4 over to the left. So on the left-hand side, I get 6x log 3 minus 2x log 4. And then moving this log 3 over to the other side, I'm going to have negative log base 10 of 3 minus 2 log base 10 of 4. I'm going to isolate the x's on the left, and in doing that, I get 6 log base 10 of 3 minus 2 log base 10 of 4. And then that equals this over here, negative log 3 minus 2 log base 10 of 4. I'm going to divide both sides by this value right here, this value right here. So I'm going to get x is equal to the opposite. I'm going to factor out the negative sign and then do that at the same time. So I'm going to get negative log base 10 of 3 plus log base 10 of 4. And remember, that's squared because of the power rule. That 2 goes up to the top. On the denominator, I'm going to have this. And so that's going to also use the power rule. I'm going to get log base 10 of 3 to the 6th power minus log base 10 of 4 to the 2nd power. So I have this divided by this. And without using a calculator, I'm going to simplify this as much as possible. And remember, add means multiply. So realistically, on the numerator, we would have log base 10 of 3 times, I'd have 3 times 16 on top. And then on the bottom, I'm going to have log base 10 of 3 to the 6th power divided by 16, 4 squared. Now, I can definitely make this into, I could make this 3 times 16. I'm going to replace that right now and make that 48. But at the same time, when I'm doing that here and I make that 48, this right here is as far as I could go without a calculator. And that's as far as I can go without a calculator. However, with a calculator, I can definitely simplify this a little bit more, and you guys can do that. For this problem here, what I would do is first I'm going to subtract 5. So in getting that, I'm going to get 6 is equal to 2e to the 2x minus 5. And then I'm going to divide by 2. So I'm going to get e to the 2x minus 5 is equal to 3. Because what these problems are sort of like you're unraveling things, right? And so you just have to sort of peel off the layers one by one, ultimately getting to the x so you can solve for x. Bringing this out front, we're going to get 2x minus 5 ln of e is equal to ln of 3. Because ln of 3, ln being the inverse of e to whatever power, that's that inverse. And we know that ln of e, remember, ln, just ln right here, is the same thing as saying log base e. And then you've got this e here. And then what ends up happening is that log base e of e is 1, because let's just say you forgot that and you set this equal to x. You would go e to the x power equals e to the 1 power, and you know x equals 1. So log base e of e is equal to 1, and log base e of e is the same thing as saying ln of e, and that's 1. So this value right here is 1. So we have 2x minus 5 is equal to ln of 3. I'm doing this without a calculator, this part. So yes, you can plug in ln of 3. Go ahead and do that if you want. 2x is equal to ln of 3 plus 5, and then you would add 5. Divide by 2, you get x equals ln of 3 plus 5 divided by 2. And then, again, plug in a calculator, and you guys can get that value. For this problem here, this kind of looked like your exit ticket, didn't it? For this challenge, case number 5, what we're going to do is we know that this is base 10. So we're going to go base across the equal sign. So we're going to go 10 to the 3rd power is equal to 2x plus 1. So we have 100 is equal to 2x plus 1. I'm going to subtract 1. And that's 1,000 actually. Sorry about that. And then we have 2x is equal to 999. We're going to divide by 2. And I get x equals 999 divided by 2. And that's my x answer. And again, you want to make sure that your answer when you're doing these equations, logarithmic equations, is that you plug in your answer, because you have to make sure that this checks out and that you don't get a negative argument. Because remember, your argument, whatever this value is here, that argument has to be greater than 0. Can't be 0, can't be negative, has to be greater than 0. For this problem here, we're going to try to combine these two terms here so that I can then go log, base to cross equal sign. So in doing that, in order to do that, you have to have the same bases. And I thought I was going to fix that, but I didn't. So this is a base 2. And also, this is a base 2. We're just going to change that. So now that we have the same bases, we can combine them. So we're going to get log base 2 of x times x minus 1 is equal to 1. I'm going to get 2 base across the equal sign. So 2 to the 1 power is equal to x squared minus x. This is quadratic. I am going to set this equal to 0. I get x squared minus x minus 2. 0 equals x minus 2 times the quantity x plus 1. I'm going to split this up so that I do get two solutions. I get x is equal to negative 1, and I get x minus 2 equals 0, so x is equal to 2. So what you should be seeing right now is that this negative 1 here isn't going to work. Because when you plug this back in here to this negative 1 here, that value is not, it's less than 1. And so the original equation, you have to be able to plug these all the way back into the original equation. Not here, because here obviously this is going to work. But I'm not talking about here. You got to go back to the original equation, be able to plug in both of your values. So 2 works here. 2 minus 1 is still 1. That's positive. That works. So my solution set, when it's all said and done, is just 2. And then negative 1 is outside of the solution set. So it's called an extraneous solution. For this problem, I noticed that all the bases are base 10. So that's going to work in our favor, because once I combine the left side, these two values on the left, these two terms, then the log base 10 is going to actually cancel out. So on the left, I get log base 10 of x minus 5 is divided by 5, quotient rule, is equal to log base 10 of 2x minus 1. Because both of these are base 10, they have to be the same bases. They are going to cancel out. And you're left with x over 5 equals 2x minus 1. Crossing multiplying, you're going to get x equals 5 times 2x minus 1. I'm going to distribute that 5. I get 10x minus 5. Subtract x, I get 9x equals 5. So x is equal to 5 over 9. Just make sure that this plugs back in right here and that it works, right? You can take 5/9, log of 5/9, that works. 2 times 5/9, so 2 times 5/9 is 10/9. And that's 1 and 1/9 minus 1 is 1/9. So that's still positive. So this one also works. So this answer would be acceptable. For this problem, all the bases are 2. So once I simplify this right side, those are going to combine. So I'm going to get log base 2 of x plus 5 is equal to log base 2 of x minus 1 divided by x plus 1. My log base 2's will cancel, and I'm left with x plus 5 is equal to x minus 1 over x plus 1. I'm going to cross multiply, and I get x minus 1 equals, and then this times this. I'm going to get x plus 1 times x plus 5, and x minus 1 equals x squared plus 5 plus 1, so that's plus 6x plus 5. And again, this is quadratic, so we are going to set this equal to 0. So I'm going to subtract x from both sides and add 1 to both sides at the same time. So we have x squared. 6 minus 1 is 5x, and 5 plus 1 is 6. And so I'm going to factor this, and I'm going to get x plus 2 and x plus 3. I'm going to split this up. I get x equals negative 3 and x equals negative 2. Plugging both of those numbers back into the original equation, negative 2 plus 5 is 3, that works. Negative 2 minus 1, negative, not going to work. So this value is out. Negative 3 plus 5 is 2, 2 works. Negative 3 minus 1 is negative 4, this doesn't work as well. So what that means is that I have a no solution for this problem. So my answer set will look like this. Solution, no solution in my solution set. However, outside of my solution set, I have two values that are negative 2 and negative 3, and those are what we call extraneous solutions. For this problem here, again, unraveling this to make this set equal to find x. So we're going to divide by 2 first, and then we're going to get ln of 2x plus 3 is equal to 4. And then I'm going to replace ln with log base e. And in doing that, I still have 2x plus 3 here is equal to 4. And this e will then base to across the equal sign. So we're going to have e to the 4th power equals 2x plus 3. And I'm going to subtract 3. I get e to the 4th power, which is, you know, the 2.71828, but that value to the 4th power. It's just a number. Minus 3 is equal to 2x, and then x is going to equal to e to the 4th power minus 3, all divided by 2. And you can get an answer to that. If you have a calculator, you can do that. Case number 10, you are simplifying this expression. It's not an equation. We're not solving for x. Okay, so power rule. See this 4 here? That 4 is going out front. So that's really saying 4 times ln of v. ln of v is 1, so this is 4. So just this is done. This value here, the bases are the same. That means that's 3. My answer is 3 plus 3. This value here is saying the square root of 4, which is 2. So plus 2. And this one right here is saying 8 to the 2/3. So 8 is actually 2/3. And then we are going to make that to the 2/3 power. 3's are going to cancel. So I've got 2 squared, which is 4. So that's plus 4. So what is that? 4 plus 4 is 8, 9, 10, 11, 12, 13. So my simplified answer is 13. So this is for the quiz review. This is specifically just for the quiz review. And so let's get started on that. Your job is to simplify the exponential expressions. So this is saying the opposite of this value. Now remember, this is cube root. So that's going to be okay with that negative sign. So we have the opposite of 5. This is 5 to the 3rd power to the negative 2/3 power. 3's are going to cancel. I have the opposite of 5 to the negative 2nd power, which is going to be the opposite of 1 over 5 squared. So 1 over 5 squared is 1 over 25. And there's my answer. Okay, these are expressions. There's no equal sign. There's no x. I'm going to distribute this negative 3 first. So unless I can cancel. Always try to cancel if you can. I can't. So we are going to simplify this. I'm going to shrink this up a little bit. Looks like I'm going to have 2 to the negative 3rd, x to the negative 6th, over, and this negative 3, remember, goes to every term inside here, top and bottom. So that'll be 5 to the negative 3rd, y to the positive 15. And then my final answer, when I move the 5 to the 3rd to the top, is going to be 125. 2 to the negative 3 will go to the bottom at 8. X to the negative 6 will go to the denominator and make it a positive 6 power. And y to the 15 just stays there because you're really not doing anything with that. And so that's your answer, and box that up. That's it. Okay, that's as simplified as that gets. For this problem here, numbers get multiplied with numbers. See how these are not in parentheses? Otherwise, if this was a parenthesis like that, I would have to distribute that negative 2/3. But because there's no parenthesis, I'm just going to take the bases that are the same and add the exponents and then multiply the numbers. So that means negative 3 times 5 is negative 15. And then I've got x to the negative 2/5 plus 4/3. And so I got to get a common denominator, which is 15. So I'm going to multiply that by 5 over 5. And this I'm going to multiply by 3 over 3. So I get negative 6 plus 20, which is 14. So I get, my final answer is going to give me negative 15 x to the, what is that, 20? No, what did I say? 14 over 5. So 14 over 5. So realistically, you're going to leave this like this, but if you chose to make this into like roots and stuff like that, you completely can do that. This is the 5th root, which basically means every time I have 5 x's, I can take 1 out. And notice I have 14 here. So what that means is that I can take out 2 x's, so this would be x times x, which is x squared, and then you'd have a square root or 5th root of x to the 4th power. Okay, so you could rewrite it like that if you wanted to, but just leave it as a root, fraction is fine. For this one here, try to simplify as best you can. I know that 15 will divide into 60. 15 goes in there once, and 5 times here for 60. x squared, and I'm going to do this down here now. I know this 5 is here. See this x squared? This now, because it's a -2, is going to drop down to the denominator. And because of that, now I've got 3 plus 2, so that's 5. This y to the -5 is going to come up to the numerator. So I've got y to the 4th and y to the 5th on the numerator, so that's going to be y to the 9th. And for this problem here, z's, it looks like I'm going to take this -12 and bring it to the numerator, so that's z to the 12th. And what that means is I've got -10 plus 12, which is 2. So that's going to be z to the 2nd power. Now, definitely there's different ways to do this problem, okay? This is just one way to do it. Other ways to do this problem might be something like, let's see, might be just saying, okay, let's say I want to find my y's. I would go for minus -5. Minus negative is y to the 9th. That goes up on the top. Okay. Yeah. Okay. And let's see. 2 is 34. Oops, did I mess up on that? 15. That should be a 4, by the way. So, yeah, let me fix that, because 60 divided by 15, fun fact, is 4. Okay, all right, next problem. Distributing that 4, we're going to get, well, actually, before I do that, I'm going to reduce. So reducing is going to give me, still the 2/3 stays. And reducing, I've got 2 x's canceling with these 5. So that leaves me 3 at the bottom. Canceling 7 minus 2 is 5. So that there's 5 y's up at the top. And then all of that is going to be to the 4th power now. Okay, so bringing in the 4th power after I reduce is just going to drop down the numbers a little bit less. So 2 to the 4th is 16. So I have 16 y to the 20th. 3 to the 4th is 81 x to the 12th. And so this would be my answer for this expression when you're just simplifying that. For this problem here, I can get bases the same. I notice that this is 81, which is 3 to the 4th. And then if I bring that up to the top, I get 3 to the -4th power equals, and 9 is 3 squared to the 2x minus 5. And then that's going to be -4 equals 4x minus 10. I'm going to add 10 to both sides, so that's going to be a 6 is equal to 4x. And then x is equal to 6 over 4. Dividing by 2, I get 3 over 2. And then you just put that in solution sets. Okay, 3 squared. Okay. For this problem, though, you're going to use a calculator because I'm not going to be able to get the bases the same. The first thing I'm going to do, though, is divide 68 by 4. And 68 divided by 4 is, what, 17? So I have 7 to the x power equals 17. I need to get this variable, this exponent out of the variable out of the exponent's power place. So that's going to log on both sides. So we have x log 7 is equal to log 17. So I get x equals log of 17 divided by log of 7. And remember, if you don't have a calculator, you would write that like this, log base 7 of 17, and that would be your answer. But if you do have a calculator, you're going to actually find the value of that, and that's going to be, let's see, log 17 equals divided by log 7, and I get 1.4559 or 456. So it's about 1.456 would be my value for x. Put that in solution sets, and then you can box that up after that. For this problem, also, I'm not going to get common bases, so that I'm going to log both sides so that x goes out front. So we have x log 6 is equal to log of 92. So x equals log of 92 divided by log of 6. And I can rewrite that as log base 6 of 92. You're going to want to put that into a solution set, so give me an answer for that. So that would be log of 91 divided by log of 6, and I get 2.5176. 2.5176. Okay. For this problem here, you're going to convert this from log to exponential, find the inverse. So we're going to say 36 to the x power equals 216. I don't know if I can get common bases. Let me see. 216 divided by 6 is 36. That's going to work. This is 6 squared to the x power. And 216 is 6 to the third power. So bases are the same. 2x equals 3. So x equals 3 over 2 again. Now for this problem here, just note that, yes, I absolutely could have gone from here and brought that out front and said x log 36 equals log 216. And then x equals log base 36 of 216. So and then found that answer, which is 3/2. So you also could do something like that if that, works better for you. For this problem, you're trying to solve this equation for x, so you need to get rid of this first. So I'm going to take 122 and divide it by 3.26, and I get 14 to the 0.7x is equal to 37.4233. And then I'm not going to get the bases the same, so you need to log. So we're going to pull the exponential value x out of the exponent's position and log both sides. So we get 0.7x log 14 is equal to log 37.4233. And then I'm going to divide both sides by log of 14. So I'm going to take that value and I'm going to log that. I'm going to say answer. And I'm going to take that number and divide that by log 14 on my calculator. And so now I have 0.7x, that's a 0, almost thought it was a 2 for a second, is equal to 1.3726. Now I'm going to divide that by 0.7. So take that divided by 0.7. My final answer for x is equal to 1.9608. So just a note, on these problems, you need to make sure that you are getting the right answer, especially if you can check your work. So it's completely fine. You should have enough time, especially during the quiz, to plug this value back in to x and multiply by 0.7, go 14 to that power times 3.26 should yield the 122. If you're not getting that, then, obviously you made a mistake and you should revisit that. For this problem, we are trying to figure out what this equals. This is 3 to the x power is equal to 81. We know that 81 is 9 times 9, which is 4 3s, and that's 3 to the x power. If the bases are the same, I can set my exponents equal to each other, and I get x is equal to 4. For this little review part, this is just saying solve for x, choose the right answer, okay? So this one, I'm going to get common bases, so that's going to be 3 to the x minus 2 is equal to 3 cubed to the x power. Bases are the same. I can say x minus 2 equals 3x. I'm going to subtract x. I get negative 2 equals 2x. So x equals negative 1. So that's this value. For this problem here, they gave me values. I'm trying to take log base a of 98 and break that down, but only using 2s and 7s. So I would start off saying 98 divided by 2 is 49. So if I'm over here and say 98 divided by 2, I get 49. And I know 49 is 7 times 7. So if I rewrote this log, what I would get is log base a of 98, which is 2 times 2 times 7. So that's going to be 2 squared plus log base a of 7. The a's are the same. The bases are the same, right? This 2 is going to go out front. So I'm going to get 2 log base a of 2 plus log base a of 7. So log base a of 2 is x. So this right here is x. So that's 2x. And plus log base a of 7 is y. So this is 2x plus y. And so my final answer for this problem is C. And this problem here, ln, natural log goes the same way as your logarithms. So this is actually saying ln of x to the 1/4 power. Add means times. So that'll be times y. Minus means divide. So now I'm dividing by this 2 power rule, z squared. Okay, and I don't see this exactly the way I wrote it, so I'm going to try to rewrite it again. ln of the 4th root of x times y all over z squared. Let's see, ln of the 4th root of x, that's not right. This is, you can't put ln on both sides. This one, what's wrong with this? ln, oh, that has ln at the top. That's not right. Can't have ln on the top and z on the bottom. This is not simplified, so pass on that. This one's out because of the ln. ln has to be in front because it's for a quantity. Like this is a quantity. See that? Quantity. This is a quantity. And this, even this is a little questionable. Let me make sure that that's out front. And so this would be my answer. So my final answer for this problem would be D. For this here, you are not trying to condense, but for this value, you're trying to expand. And so we want to expand all this. And so rewriting this, you're going to get log base a of x cubed plus log base a of y to the 1/2 power. And then this is a minus. So minus log base a of z squared. So now I'm going to distribute those powers. And so I'm going to have 3 times log base a of x plus 1/2 log base a of y minus 2 log base a of z. And then that would be my answer. And this problem here is taking this whole thing and asking you to make this into a single logarithm. This 1/3 actually goes to this value here. So let's see, we've got all of them are log base a. So we have x squared minus 1, and that's to the root 3 power, minus, so that means we're dividing, log base a of y, so that's just y, and minus, again we're dividing, log base a of z to the 4th, so z to the 4th. And then just to be clear, I would make sure that I put parentheses out front, and so I'm going to rewrite this, I'm going to rewrite this just to make sure I can fit my parentheses in there, because I want that log base a to be outside. And then just parenthesis for that quantity. And lastly, we have expand this value here. We have log base 2 of a, and then divide means subtract. So that's going to be minus log base 2 of 3 minus log base 2 of b, and then this is the cube root of b, so that's b to the 1/3 power. Just be very careful, because watch for things like this, log base 2 of 2, because that value would yield 1, right? So just be careful with that. And especially if this one was log base 2 of 2 to the 1/3, that 1/3 up here would have been brought out front, and that would have been 1/3 times 1, which is just 1/3. So that's, you'll definitely see that on the test. Just make sure you watch out for that. So for this problem, to finish, we're going to get log base 2 of a minus log base 2 of 3 minus log base 2, 1/3 log base 2 of b. And the only other way to write this realistically is this one way, is log base 2 of a, and then you could subtract this quantity, which is log base 2 of 3 plus 1/3 log base 2 of b. And you're welcome to do that and subtract a quantity, but just remember that that minus sign out front does go to both terms inside, so they are both negative. So, and then this would be my final answer for this problem. So good luck on your quiz. You have no homework tonight, right? So that's awesome. Thanks for watching, and have a great rest of your day.